Hello, welcome to video 3.6b Slant Asymptotes. Again, review from Algebra 2 and Pre-Calc. So although it's new for us right now this year, a slant or oblique asymptotes, it is Algebra 2 Pre-Calc review. Okay, it only occurs when you have a rational function, y equals a polynomial over a polynomial, where the degree of the numerator is 1 more than the degree of the denominator. If it's 2 more, there's no slant asymptote. To find the equation of the slant asymptote, you're going to divide the numerator by the denominator, and the slant asymptote is going to be y equals the quotient you get. You're going to ignore the remainder. Now, there's two kinds of division. There's synthetic division and long division. Obviously, synthetic division is a lot easier and faster, but synthetic division can only be used if the denominator is a linear binomial. So it has to be a binomial, and it has to be degree 1. So the best time to use synthetic is if your denominator is x plus or minus a constant. You could use synthetic division if you were dividing by 2x plus 3. It's very complicated. You have to factor out the 2 and look at it as 2 times x plus 3 halves. You have to do synthetic division with 3 halves, and at the end you have to come back and deal with the fact that you took out the 2. Honestly, not worth it. Okay, long division, of course, the key thing is that you have to have both of the numerator and denominator, or what you can call the dividend and the divisor. Both of them have to be in order of decreasing exponents, and you have to fill in any missing terms. Okay, so here they're already in order. There's no missing terms. So for synthetic division, I just take the coefficients of the numerator, 1, negative 3, and 1. I take the opposite sign here, which is negative 2 instead of 2. Bring down the first coefficient, which is 1. Multiply the 2 together, which is I'll do it your way. This is the fast way, but this is the way you guys are used to doing it here. Okay, so you bring down the 1. Negative 2 times 1 is negative 2. Add that to negative 3, you get negative 5. Multiply, you get positive 10. Add, you get 11. The only step I'm not doing in my table right here is I'm not doing this step. I'm going, whoa, get this. I'm multiplying by negative 2 and adding it to negative 3 all in one step. Isn't that amazing? And then I'm multiplying negative 2 by negative 5, holding that number 10 in my head and adding it to 1 to get 11. Anyways, if you did long division, you'd have this. You'd ask yourself, x times what gives x squared? X times x gives x squared. You multiply the x times x plus 2. You get x squared plus 2x. Remember, you are subtracting this, just like long division. X squared minus x squared is gone. Negative 3x minus 2x is negative 5x. The first place I'm going to look, if you have negative 1x here, you add it instead of subtract it. Bring down the next term, which is plus 1. X times what gives negative 5x times negative 5. Negative 5 times x plus 2 is negative 5x minus 10. We're going to subtract that. So that becomes negative 5x plus 5x is gone, and 1 plus 10 is 11. So either way, you get your quotient of x minus 5, your remainder of 11. Here your remainder is 11. This will be the constant term. This will be the coefficient of the x to the 1, or the linear coefficient. So there's your x minus 5, which is your quotient, and then plus your remainder over the divisor. However, our slant asymptote is just y equals the quotient. Reason being is we are talking about the far right and far left end behavior, and of course, as the limit as x goes to infinity of the remainder over the divisor becomes 11 over infinity, which goes towards 0. So it's just y equals the slant asymptote. Ignore the remainder. Okay, so this is like number 14. And of course, the directions at this point are analyze and sketch a graph of the function, label any intercepts, relative extrema, points of inflection, and asymptotes. And of course, I'm going to pick out the ones that have a slant asymptote, which is when the degree of the top is 1 more than the degree of the bottom. You'll notice none of these have slant asymptotes, right? Over here, number 13 does. Degree of the top is 1 more than degree of the bottom. Same thing with 14, same thing with 15, same thing with 16. And then there's no fractions anymore, so there's no slant asymptotes anymore. Okay, so We have x cubed over x squared minus 4. Degree of the top is 1 more than degree of the bottom. Hence, we're going to have a slant asymptote. We're going to need to do long division. We're going to put our terms in decreasing order, which they already are, but we're going to have to fill in any missing terms. And I have to use long division here because this is not linear. You cannot use synthetic on with a quadratic divisor. So we have x cubed, and I got to fill in all the missing terms, plus 0x squared plus 0x plus 0, x squared minus 4, I got to fill in the missing term, x to the 2 plus 0x to the 1 minus 4. X squared times what gives x cubed? X squared times x gives x cubed. Multiply x by this, you will get x cubed plus 0x squared minus 4x. Remember, you are subtracting each one of these terms. So x cubed minus x cubed is gone. 0x squared minus 0x squared is 0x squared. And 0x plus 4x is plus 4x. Then you're asking yourself x squared times what gives 0x squared times 0. So these will all be zeros. And you've already brought this term down here. And so your remainder is 4x, but we don't care about the remainder. The key thing is our quotient is just x, so our slant asymptote is y equals x. So I'm not doing the whole graph. I'm just talking about the slant asymptote. So number 12, we are going to do the whole graph. So here's number 12, x plus 32 over x squared. Hi, sorry, phone call. Okay, so what they're asking you to do is analyze and sketch a graph, label the intercepts, relative extrema, points of inflection, and asymptotes. Okay? All right. So x plus 32 over x squared, I would rewrite it as a single fraction, just easier to observe and decide on things. So if I have a common denominator of x squared, that's times x squared times x squared. So as you can see, it is a rational function, polynomial over polynomial. The domain, of course, x can be anything except 0 because of the denominator. Your vertical asymptote is x equals 0. Your horizontal asymptote, of course, there's none, and you do have a slant asymptote because the degree of the top is less than the degree of the is 1 more than the degree of the bottom. So I do have to do long division. I cannot do synthetics because that's squared. I have x cubed plus 0x squared plus 0x plus 32. I have x squared plus 0x plus 0. X squared times what gives x cubed? X. Multiply that. Subtract. Bring down the next term. And x squared times what gives 0x squared times 0, and then subtract, and you'll have a quotient of x and a remainder of 32, and our slant asymptote is y equals the quotient of x. Okay, the y-intercepts mean we replace x by 0. Of course, there'll be none because that'll give you a denominator of 0, and we already know that there's the domain, there's a vertical asymptote at 0. X-intercept is replace y by 0, and a fraction is 0 when the numerator is 0, so that would be when x equals the cubed root of negative 32, which does exist. Okay, so now we're ready to take the derivative. Now I did a quotient rule. I didn't really need to do a quotient rule. I could have rewritten this as x plus 32 times x to the negative 2 and actually gotten there a lot faster. Nice review of the quotient rule. Anyway, when you're all said and done, you end up with this right here. And this happens to be, by the way, the difference of two cubes and factors quite nicely. So your question is, when does this first derivative equal 0? Obviously when x equals 4. And if you try and set this equal to 0 and use the quadratic formula, because you can't factor it, you'll get imaginary numbers. So the only critical number that makes it equal to 0 is 4. The only number that makes the first derivative undefined is 0, but remember 0 is not in the domain. It's a vertical asymptote. So we put our one and only critical number 4 and our vertical asymptote on a number line, and we check, and we find out that f is increasing, decreasing, and then increasing. Now, of course, there's no relative max here because there's no points there. It's a vertical asymptote, but there is a relative min at 4 because the graph decreases on the left and increases on the right. That relative min will happen at 4 comma, and then you go back to the original function and have 4 plus 32 over 16, which is 4 plus 2, which is 6. The second derivative, okay, trust me, after you find the second derivative, it's 192 over x to the 4th. That is never going to equal 0 because the numerator will never be 0. It'll not exist when the denominator is 0, but again, it's not a crucial number because it's not in the domain because it's a vertical asymptote. So I actually only have the vertical asymptote to put on my number line, and when I check it out, of course, no matter what I plug in, since that exponent is even and that's positive, I'm going to get positive on both sides, so the graph is concave up on both sides. Now the trick is to put everything together. So here's our one and only x-intercept. Here's our vertical asymptote. Here's our slant asymptote. I know that on either side of, I know the graph is concave up the whole time. I know there's a relative min at 4, 6 with a horizontal asymptote there. It decreases and increases and is concave up. Make sure your graph approaches the actual asymptotes. If you draw this, then your graph is not approaching your asymptote. It's just getting further and further away. I will take off points. Again, here it's got to go through that point. It's concave up the whole time, and it's got to approach both of those asymptotes. Okay? Number 58, now the directions here changed a little bit. 58 says use a graphing utility to graph the function and determine the slant asymptote of the graph. I'm not going to bother with the rest of those directions. So if you graph this on your calculator, you will see the following. It's barely noticeable that there is a slant asymptote right here. Obviously, there's a vertical asymptote at x equals 5. But you know there's a slant asymptote because the polynomial on the top's degree is 1 more than the polynomial on the bottom. So to actually find the equation of the slant asymptote, which I can tell you right now, your calculator cannot do in the graph screen. There is no slant asymptote, functionality. So I'm going to take my 2x. Now everything's in order already. There's no missing terms. And I'm using synthetic because it's divided by x minus 5. And my remainder is negative 5, but this is my constant. That's my linear coefficient. So my quotient is y equals 2x plus 2. Make sure you write y equals 2x plus 2. And that's the end of video 3.6b.